So we go to so we come to problem 6.12. Problem 6.12 and so by analyzing equilibrium at points A and C, determine the tensions in members B, C, A, B, and C, E. I think I've made a short. The original question is much longer. The original question in on page 313 is much longer as far as I remember. I'm sorry, not 31. Yeah, 313. The original problem asks you to determine forces in all members, but I'm just asking you for three uh, these three members. Now, we follow the SOP for dealing with this problem. So, for this part, this is the same as chapter 4. And please prepare it at home. And from here, we can know that and H, we have. Oh, by the way, and for take a look of the support conditions here to left and to the right. So what kind of support do we have on the left at point A? What's the name of this type of support? Roller support. Good. And H. What kind of support do we have here? Pin. So for the free body diagram, and I'm not drawing the members in between, but for example, at A and at H, what forces do we have at A? How many forces do we have at A? How many? 1, 2, or 3? For for roller support, for roller support, for roller support, do we have? Can we move to the left and the right? Can we move to the left and right? Yes. So we do not have a force there. Can we move up and down? No. So we have a force going. Let's say going up. And can it rotate? Yes. So we don't have a moment. And for point H, we have a pin support. For pin support, can we move to the left and to the right? No. So we have a force to the, let's say, to the right, X. And can we move up and down? No. So we have a force HY. Can we rotate can you rotate at point H? Yes. So we don't have a moment. So we will have these three support forces. So from here we will know. From here we know. From here we get these three equations. We get these equations. So we have these results, and hx equal to 0, and ay is 4 kilonewton to upwards, and hy is 4 kilonewton upwards. Now for I I I I assume or I think or you should be able to do this on Friday for determining support forces. Is that okay? It is part of chapter 4. It's not part of chapter 6. This kind of thing. Now we come to determining the forces. The I've now written down that by analyzing equilibrium at points A and C, and then to determine B, C, A, B, and C, E. Now we do it like this. At point A, okay. At point A we have how many members connecting point A here? How many members or which members? Member A, B, and AC. So we have TAB and TAC here. And we have 4 kilonewton going to the upwards. And we have how many? We have 1 kilonewton going downwards. And then we have beta here. And tangent theta this time is should be 3/4 now. Okay, now how many equations? How many equilibrium equations do we have? How many equations can we write from this three-body diagram? 2. Okay. Summation fx equal to 0, and remember to the right. So we have TAB cosine theta plus TAC equal to 0. And summation Fy equal to 0 leads to minus 1 kilonewton plus 4 kilonewton and plus TAB sine theta equal to 0. Now, I will leave these two equations here first, and we go to point C. Let me put these two equations here, and we go to point C. And how many members connect with points, or which members connect with point C? CE. What else? CB. Yeah. And CA. AC. Now we can still write two equations here. and we can write two equations here. And TCE minus TAC equal to 0. This is summation Fx equal to 0. And summation Fy equal to 0 is TCB equal to 0. So thank you for pointing out this point B here. Now, and how many equations do we have? We have how many equations do we have? We have 4 equations, and how many unknowns do we have? The unknowns are TAB, TAC, and this one is this TAB is this TAB is this one. So we have TCE and TCB because TAC is this one. Okay. So we have 4 equations and 4 unknowns. Now, and you can use then you should be able to solve it, and of course you can use determinants to you can of course this one TCB is equal to 0, and for the other 3 you can use the determinant method in the at high school to like what I forgot, something like x1 equal to this kind of thing, and you can do this. Have you learned this at high school to solve equations? Who has seen that? And x1 equal to this one over this one, and x2 equals to. Who has seen this before? Can you raise your hand? One. Other. No. Okay, 2. Okay. So and I'll show it on Excel when I have time. That and usually and because for example that of course in this kind of problem we have 3 equations or 4 equations and 4 unknowns, and it is easy to solve. But for the problems that I'm asking my master student, or we are asking our TA to do it at in the lab, that we are talking about 10,000 equations and 10,000 unknown, and we need to solve them at the same time. Okay, and I will show you how do we do it, and in our lab. Okay, so afterwards, let's say we have solved this, and we will come to this, and TBC is equal to 0. Sorry, I made this. I made typo here. And TAB is minus 5 kilonewton, so it is in compression. And TCE is plus 4 kilonewton, so it is in tension. And before we take a break, and let me explain. Let me talk about this thing. And here we it's it shows that TBC is equal to 0. In the textbook, and it is called a zero force member. In Chinese, it is this one. Uh, some professors like talking about this, and but I don't. So and I won't. I won't spend time discussing this. But sometimes it is normal that after calculations, and you will find some of the members have zero force in it. Okay, and it is normal. So and and it has a name, but I don't think it is useful. Now, for what's the time now? And so let me have a